Alright, today's class is on polishers and regens. So we have 3 polisher vessels. What flows through the polisher? Ooh, bad guess. Condensate. So you're coming from the condensate pumps. Let's see, let's have a hot well. Let's have a condensate pump. And that one. And then you're going on to the DA, and then to the feed water system, and then the drum, and then the turbine. Alright. What is the purpose of the polishers?
Clean the condensate back up.
Clean the condensate, yes. How does it do it?
Changes ions.
Ion exchange. So it's not cleaning like physical particles. It's cleaning stuff that's dissolved in the water. So the water is in tubes. The tubes are made of steel. The steel has ions that get in there, and we got to get those back out. All right. What is an ion?
Particle or like.
I mean, you're not wrong.
It's not right. Is it a negative charge? I don't know.
All right. So an ion is a charged particle. It is an atom that has lost or gained an electron, so it is either positive or negative charge. Could be either one. The positively charged ions are called cations, because the T and the plus look the same, and the others are called anions, because they're the other ones.
Makes sense.
Yeah, it makes as much sense as anything. All right, so the polisher is removing things like sodium and silica, and it is replacing that with hydrogen ions. And it is removing things like, mine's blanking, chlorine, because that's part of salt, and that's why I know that's negative. And it is replacing that with hydroxide, which is OH negative. And then since you're putting in hydrogen and you're putting in the hydroxide, then those combine to make water. And that's how you're putting stuff in, but it stays pure. All right. I think I made a tactical error already. The bypass valve around the polishers, not to scale. When do we use the bypass?
Temperature is too high.
Okay. That was not the first answer I was expecting, but that is a valid answer. Inlet temperature of, I think it's 180. I might be making up that number. High inlet temperature will make the bypass come open so that we don't melt all these beads into one big chunk. What else?
Pressure.
Differential pressure. So at a 50 pounds differential, this guy opens up because these beads are held in by screens and too much pressure, and you'll start ripping the screens and forcing the beads through the screens, and then we'll have freaking resin beads clogging up the feed water pumps. That shit's never happened here. Yeah.
Have we melted them before?
We have not melted them before either. I will say that when I was in the Navy, our ion exchangers had 140 degrees on their protection, but then that's all nuclear stuff, so everybody's like extra conservative. All right. It also comes open when you don't have any condensate pumps running. So when you start your first condensate pump, you don't slam into the resin beads. It has a path around it. And then there's another time that we open it in manual. When's that? No, not regen. Okay, the answer is most of the time
When we're on one polisher.
when we're using one polisher. So it takes two polishers to be able to have enough flow to keep normal operations going. Normally our chemistry is so good that we only have one polisher in service and we have the bypass open 50% and it works. We tried changing the set point on this to have a DP set point so that when you dropped load it pinched off and you got as much through the polisher as you could all the time. And it turns out that this is a butterfly valve which doesn't throttle for shit. And so it was just swinging pressure all over the place and not a workable plan. Alright. So polishers, resin beads, removing cations, replacing them with hydrogen, removing anions, replacing it with hydroxide, hydrogen and hydroxide combine to make water, system stays pure. What is the thing we're removing the most out of the system?
Silica.
Silica is the most important thing? I don't know. Silica is the thing that we're worried about.
Sodium.
No,
Ammonia.
Chlorine?
somebody said it. Ammonia.
Ammonia? Oh, yeah, that's right.
Why is there ammonia in the system?
pH control.
We put ammonia in the system on purpose to raise pH. And then that ammonia becomes NH4 plus and OH negative because we combine it with water. That's where the... So in water, ammonia becomes this, and then this raises pH. Oh wait, hydronium ions is what's raising pH. And then this goes to the drum, this carries over the steam, this ends up back in the hot well, and then it gets pumped up to the polishers, and then the polishers go, oh, ions, I'm getting rid of those. So all this NH4 plus gets removed and replaced with H plus, which then combines with OH negative, turns to water, goes away.
And put more ammonia in, brings it back.
Then we have to put more ammonia in to get pH back to set point. That is a true statement. So if we didn't have polishers, we would have to treat the water way less, which is another reason we like bypassing with polishers, is because an ammonia tote lasts like 3 times as long. All right. So somebody brought up silica. Silica is one of those one of those ions, and the reason we don't like it is because when it carries over in the steam at high temperatures, it wants to plate out. So it wants to, in all the steam tubing, the silica would build up like an insulating layer, and in particular, they're worried about it building up on the turbine blades and throwing the thing out of balance. So we have a limit of, let's go back to blue because I wrote silica in blue earlier. So silica has a limit of less than 10 parts per billion in the steam. What's a part per billion?
A bunch.
It's-
Not a lot.
It's a tiny, tiny bit of a percent, right? So if we say 10 parts per billion, that's like saying 70 people in the whole world. So it doesn't take much for this stuff to start plating out. There is an advantage that just because you get it in the water, normally coming out of the D-min, it's at 3 silica, 3 parts per billion. That's what the D-min quality water that they send over is. They being the chemists. But if the water gets higher, it's the steam carrying over that we're worried about. And not all the silica carries over. And how much carries over depends on the pressure. So the higher the pressure in the system, the higher percentage of the silica carries over the steam. And if you're in a supercritical system where you're above 3,200 pounds, then you can't really tell steam from water anymore, and it kind of all carries over. We operate at 2,500 pounds at full load, which still has quite a bit carryover. But if you get your water contaminated, you don't have to necessarily shut the unit down if you can drop load and keep the steam below the limit. And then they also have things like you're allowed to exceed 10 parts per billion as long as you're less than 100 for such and such hours a year. There's all sorts of rules in the Toshiba guidelines that say this much is acceptable. We tend to run a really clean system. We tend to do a good job of keeping all this in spec. All right. So that's operation. Next, we're going to talk about regen. How do you know a polisher is exhausted?
High throughput.
High throughput. Yes, but that's not normally how we do it.
Sodium runs.
Sodium. So at the sample, so the output going to the sample sink.
Wouldn't that be on coming off of each individual polisher?
Yeah. So
And then you'll have the one like you're drawing for the.
So there's a selector switch that has solenoid valves, so that you can take a sample off of each individual polisher as well as off the contact. And sodium. So when the sodium gets to 1 part per billion, that might be part per million. I'm feeling million, I'm not sure. So when a sodium analyzer normally reads 0.0 something, 0.05, something like that. And it'll read that way for like 5 days on a polisher, and then it'll start creeping up. And by the time it gets to a 1.0, then that polisher's exhausted. If you're running multiple polishers, sometimes you can. A good rule of thumb is the one that's been running longest is probably the one that's exhausted, right? Not all beds are the same. Not all regions are the same quality. So it's not 100% sure that it's going to go that way. So you go to the sample sink, and Danny Rhodes will tell you to do a survey on the polishers, and you've got Alpha and Bravo running. You know, Alpha's been running longer, so you turn it to Alpha. And there's sample lines that take a while for this stuff to purge through and before the numbers actually change. So you got to get to like 15 minutes or so. And if that number goes up, then that's the bad polisher. If it goes down, then oh, the other polisher must be bad. So then you go and check it and confirm that you don't have the crazy instrumentation or that whatever. And sometimes when you first flip that switch, there's stuff in the line from a previous sample that's been sitting there forever and is not telling you the truth. So before it settles out over that 15 minutes, it might go either way. Might go up, might go down. All right. So we decided that Alpha was bad. And then you go to the screen, you put Charlie in service, you watch your flows all come down, you take Alpha out of service, and then you start the transfer. So then there's 4 beds and 3 vessels. So the fourth bed is over here in the mix and hold tank. So we are going to, the system's going to, you don't really have to do anything here. the system is going to take all this and put it over here. And then there's a step where you, the operator, are supposed to go up to the window and look and make sure that joker's really empty. And then you hit proceed, and then it's going to take this and bump it back over there. And that's a transfer. I know nothing about those valves. I don't know much about the system at all. There is a 3-ring binder inside that control panel that actually has all the steps that the PLC is supposed to be going through in order and telling you what valves are doing what the whole time. You only really break that out if there's a problem. Yeah. All right. So now we've got the resin bed over here. Oh, there's signs. There's signs that say resin bed number 4. And so resin bed number 4 was sitting over here, and resin bed number 1 was sitting over here. And so you take it and you physically move the signs yourself. And then you write it down in a little book. Is that book still there? Oh, good.
Notepad.
Notepad. It's no longer one of those nice hardback green books. Cheapskates.
And there's, well, it's further into the, it's on the chemical injection. There's actually a sheet you go by for caustic and acid introduction and the percentage of that run.
All right. So then you go to the anion, so you've got a sep-an tank. That's separation and anion. And the other tank is the mix and hold tank. So you go to the sep-an screen and you hit start regen, and it has this series of back flushes it does where it's getting all the dirt. Because this is, I said that it's not a filter. It's a filter whether it likes to be or not.
You've also got backwashes on the transfer.
There you go. Okay. So it's got 10 cycles of backwashes that this thing goes through. And then it goes into separation mode. So separation mode gets like a turbulent little fluff kind of flow going up. And there's like a series of windows over here. And there's a yellow pipe that almost blocks them. That was convenient. And as it fluffs, some of these beads are designed to be heavier than others. So you will end up with all of your cation beads on the bottom and your anion beads on the top.
And if the beads are jacked up, you'll have a mixture of both of them between the 2 layers. Like the last one I did, it had about 1 inch to 2 inches worth of junk beads in it.
Okay. So the ones that are physically lighter, the anion, are also lighter in color. So you'll be able to look through those windows and you'll be able to see the gaps in the windows are bigger than that. You'll be able to see, oh, this window's light, that window's dark. I must have good separation. So this is a step you have to manually do. It says verify you have good separation. So that's what you're doing, is you're looking for a good difference between the colors of the beads.
Supposed to do it on pH.
That's
No,
when
we're not
separates
quite there
the
yet.
tank.
So then you tell it to start the transfer, and then it starts pumping this stuff out the bottom. You got a sight glass there, and pumps it over into the other one. And so you're going to be watching that sight glass and you're gonna be watching it full of the dark beads. And then there's a pH meter here, and the dark beads, which are they're positive beads, so they're gonna have a very low pH, and then that pH meter is seeing that low pH, and then when it sees the pH climb, then it goes, oh, that's it, and it stops the transfer. What percentage of the time does that work? Once upon a time, we didn't trust it at all.
Last couple times it didn't work for us.
Yeah, I still don't trust it.
I've heard people say, oh yeah, it works most of the time. But in reality, what you're really doing is you're watching that window. And when you start seeing the light colored beads go in there, then you need to hit stop on the transfer. So now we just have anion beads on one side, and we have cation beads on the other. What happens if you don't stop?
You gotta swap all the beds around, pain in the ass.
That's right. So you end up with both beds over here, and they're not regenerated yet. So you've got to do a double transfer. You got to go through all the steps of a transfer to get this bed that's good over here, and this bed that hasn't been regenerated yet back over here, and then do it again, and then start over. But when you get to those inner and outer, the backwash steps, you know it's already clean. So you can skip through all that. You don't have to spend 24 hours backwashing it. But you do have to spend 6 hours babysitting this thing through its steps to try and get it done quick, because you're behind now, especially if you're running 2 polishers. All right. So once upon a time, somebody that's no longer here missed that step, got both of them over there in the same vessel, and went ahead and started the regen anyway. Then figured out what he did and called for help. So then, Tech 3 comes down, says, oh yeah, well I can fix this, and he does the transfer, and he does the transfer back. This all seems to make sense, right? Well, he had already put acid in here, and he had not flushed the acid out. So all that acid got transferred over into this vessel. That's not too bad, right? Because the vessel's isolated, right? Well, the last step of that damn procedure is pressurization. So there is a tiny little solenoid valve going around the big valve that'll bring that up to the system pressure, and I'll be damned if that acid didn't gradually drift over, and you kind of saw it a little bit on the economizer pH dropping, and the ammonia pump picked up and tried to cancel it out. That's not really where you got the problem. The problem was that this acid didn't boil off and carry over into the steam. So it never got around to the hot well and back to the polisher and got cleaned up, and instead it just accumulated in the drum. And so the pH in the drum started dropping. And the answer was open the blowdown, cross your fingers, and freaking hope and max out the ammonia pumps and watch this pH go down and down and down and turn and come back up at a 7.5. 7.5, by the way, is the number where the control room operator is supposed to trip the unit.
Sometimes.
So, that was back in the Wild West days when nobody knew what they were doing and there were no rules on who could do anything. I don't say nobody knew it. At one point, nobody knew what they were doing. And at this point, about half the people knew what they were doing, and we hadn't properly sorted out which ones were which. And that's when the rule said, oh, it has to be a Tech 3. It has to be a Tech 3 to touch the polisher. No one else should touch the polisher. But yeah, you can mess stuff up. All right.
How'd it end?
How did it end?
Yeah.
Everything would turn out okay. They did not punch out the units. There was lots of yelling and head scratching afterwards and going, how did this happen? And what do you guys fucking do? And fucking morons.
So worst case scenario, you would have to drain the boiler.
Yeah, we would have to. That would be the thing to do. We'd stop the unit, shut down the unit, because the fires, the heat in there makes whatever chemistry thing you got going on way worse. Whatever chemical problem you have is way worse at 600 degrees and 2,500 pounds than it is on a table. And then, yeah, drain the boiler, refill it, start over. That would have been the answer. All right. So when this thing's operating, it's constantly putting hydrogen and hydronium into the system. And during this regen, we've got to get the hydrogen and the hydronium back onto the beads. So we do a chemical injection step where you have sulfuric acid. You got a tank, you got some pumps. Ooh, you got a drawdown column. I better draw that, huh?
Oh, yeah.
So you put your sulfuric acid in, you do a drawdown to make sure the right amount of gallons per minute. It goes for a certain number of minutes. There is a meter that is measuring the pH, so that and that comes up with a percentage of acid in the water based on the pH. Does it read percentage on the screen, or does it read pH?
Percentage.
On both caustic and acid.
So the acid is like a 5, acid is 5 and the caustic is an 8.
Neutral is 7. Everything below 7 is acidic. Everything above 7 is caustic.
I think he means on percentage, right?
Yeah.
Oh, hell, I don't know the answer to that.
Yeah.
Oh yeah.
Those are numbers that have been tweaked with enough since I was down there that I don't actually know. It used to be that there was like 3 steps, I want to say, where you had this concentration for this long and then this concentration. They simplified it, and I don't know what the actual numbers are.
4, 6, and 8. 4 now it's just 8 on caustic and 5 on acid. Acid at the same step. Except that it's like 2 steps.
All right. So you also have
No
caustic. And the caustic pumps and the drawdown column. And then here you go. So the caustic is putting the OH back on the anion beads. Plus. So you got to separate out the beads, because if you didn't, for one thing, the acid and caustic, when they mix together, it's a reaction that releases a lot of heat, a lot of foaming, a lot of pressure, a lot of baking soda and vinegar kind of action. Another reason is because the caustic soda has the sodium in it, and if you had the sodium on the beads, it would be more attractive to the beads than the hydrogen was, and you'd end up canceling everything out. So you got to separate it first. And then You got the water heater. I think 160 is the set point.
170 is visual check.
Visual check on the thermometer that didn't work?
Yeah.
Okay. So
It's,
But the actual temp going into the bed is what, 120?
that is correct, but so the 170 water goes in the mixing
Yeah.
valve, mixes with the caustic, and you get 120.
yeah, I can't think of the word for it, the actual step that it's calling for is 170 for a visual check off the heater, and then you can move them.
So this caustic soda actually gets like denser and sludgy as the temperature goes down, and somewhere around 40 degrees, it's like syrupy. And that's one of the reasons we've got those electric heaters in the polisher chemical room, is to try and keep this flowing. Did you say 8% on the top?
Yes.
Which is the two, I know those are two of the steps that you have to actually sit there and watch. You gotta make sure that the pumps are running and it's getting at 8% and 5%.
Yeah, once you get to separation, you have to stay there. You're looking at 2 hours, good 2 hours for separation and chemical injection.
Yeah, so separation was make sure this tank's empty, make sure you got good different colors, make sure it stops when it's supposed to, and then you got to do the drawdown on the acid injection, monitor that. You got to do the drawdown on the caustic injection, monitor that.
It makes sense now. Now, because when I was used to hear something like separation.
What do you separate?
Yeah, that's what I was
Yeah, so it's a mixed bed ion exchanger, and when we say mixed, it's because there's two different kinds of beads that are all mixed in. And then
Okay.
you got to separate it to regen.
So once you get those beads back, because you say it screens in the polisher, right? So how do you?
How do you keep them in the polisher?
Well, no, because once you get them, once you regen them, right, you putting them back in the polisher.
Okay, give me 2 steps to finish regen.
Okay, I'm sorry.
So we've done our chemical injection, then it does a flush thing on each thing separately, and then there's another step where it pauses, and then you got to say yes, we're ready to mix it, and then it'll take the green beads, the anion beads, and mix them back in, and then there's another flush, and then we're done. Oh, there's a neutralization tank I should probably mention, huh?
There's not a screen separating beads in the polisher. Is that what you're thinking?
Yeah.
No, they're mixed together in the polisher.
Oh, okay.
Yeah, once they go to the tank that he just put everything in,
The
they're-
screen.
there's the mix and hold tank. They're still separated. The green will be on top and the blue will be on the bottom. And then the air scour blower will fluff it up and mix them.
But the screen that Shad was talking about keeps it from going into the system.
Oh, that's the screen.
Yeah.
Oh yeah, that's where the confusion was. Okay, yes. All right, neutralization tank. So during these rinse steps, especially when you've got this acid and this caustic that you just put in the system and you're rinsing it out, then that has to go to the neutralization tank. And the neutralization tank has pumps, and then those pumps recirc, and then it has a pH meter, and then it has an air operated valve, and then it goes out to some 3. Am I wrong?
And
And
point in research that on.
So you are recircing to monitor that pH and make sure that it's acceptable range to go out to sump 3, which is what, 6 to 9?
Yep.
So if it's not within that range, then you're supposed to add acid or caustic to the neutralization tank and get it back in that range.
But most of the time, you can go over to the Chemtex and ask them if they need pH rolls on the pond, and they'll say yeah, and you buy that.
Okay. So we use it as unofficial pH treatment.
Yeah.
I probably should have said that on a recorded line. All right. That is polisher operation and regeneration.
Once the conductivity comes down on the mix and hold tank, it'll either go, before it comes down, it'll go to the neutralization tank. Once it gets down and it's still rinsing in, it'll switch over and just go straight to sump 3.
Because we don't need to neutralize clean water.